Chapter 7. Ionic Equilibria. 7.1 Acid and Bases. Salt Hydrolysis. The learning outcomes for this lesson are, to explain qualitatively salt hydrolysis, using hydrolysis equations, and classify the salts formed from the reaction between, A. Strong acid and strong base, B. Strong acid and weak base, C. Weak acid and strong base. In this video you will learn about salts from strong acid and weak base. Let's take a look at salts from strong acid and weak base. The salt formed from strong acid and weak base is called acidic salt. Only the cation that will hydrolyze. For example, ammonium chloride and ammonium nitrate. Let's look at an example from this type of salt, such as ammonium chloride. Ammonium chloride is formed from ammonia, reacts with hydrochloric acid, where ammonia is a weak base, and hydrochloric acid is a strong acid. Then, when the salt, ammonium chloride dissolve in water, it will produce ammonium ion, NH4+, and chloride ion, Cl-. The ammonium ions act as Bronsted-Lowry acid, and donates a proton to water. On the other hand, chloride ions do not react with water. So, ammonium ions will undergo hydrolysis with water, to produce hydronium ion, and ammonia, while chloride ion do not hydrolyze with water.
Let us study the processes that take place in an aqueous solution of ammonium chloride. When added to water, this salt undergoes complete dissociation into ammonium cations, NH4+, and chloride anions, Cl-. The ammonium cation behaves as a weak acid in an aqueous solution, donating protons in a reaction with water. Thus, the concentration of hydronium cations, H3O+, increases, which makes the solution acidic.
As in video, cationic hydrolysis of ammonium ion, produce more hydronium ion, which result in formation of acidic solution, with pH less than 7. Now you try for salt hydrazinium chloride, N2H5Cl. Firstly, write the dissociation equation for hydrazinium chloride. Hydrazinium chloride, when dissociate in water, it will produce hydrazinium ion, N2H5+, and chloride ion, Cl-. Some hint: hydrazinium ion is from hydrazine, which is a weak base, while chloride ion is from hydrochloric acid, which is strong acid. Therefore, chloride ion does not hydrolyze with water. Only the hydrazinium ion that will hydrolyze by donating its proton to water, and produce hydrazine, and hydronium ion. As the cationic hydrolysis of hydrazinium ion, produce more concentration of hydronium ion, H3O+, the value of pH become less than 7, which make hydrazinium chloride is an acidic salt. Take a look for another example of cationic hydrolysis.
All cations in salts that are conjugate acids of weak molecular bases behave similarly to the ammonium ion when added to water. For example, in hydrazinium hydrochloride, the hydrazinium ion N2H5+, which is the conjugate acid of hydrazine, N2H4, reacts with water to produce hydronium ions. Many metal cations also undergo hydrolysis in an aqueous solution. For example, the zinc ions formed by the dissociation of zinc chloride in water react with the water to form the slightly soluble zinc hydroxide and hydronium ions. A zinc chloride solution is thus acidic. Aluminium chloride undergoes similar reactions in an aqueous solution. Only metal ions which form strong bases such as sodium ions, potassium ions, and calcium ions does not undergo hydrolysis in an aqueous solution.
Thank you for watching this video, Salt Hydrolysis Part 2.